Hello and welcome back to Mr. Powers Teaches Algebra. I want to talk about inverses today. I'm going to do a really simple way here first, and then we are going to go over how to find inverses given a function with an equation. Okay? So let's say I had this basic function f. I got these values in a domain 5, 7, 8, 10, 11. I got these values in a range 8, 9, 22, 5, 6. And it's just going straight across here. 5 is going to go to 8, so I get 0.58. 7 goes to 9, I have a 0.79. 8 goes to 22, I got a 0.822. So this is a function, and it's 1 to 1. Okay, great. So let's see here. It's 1 to 1. Okay, so what's an inverse? So we should start off with the definition of an inverse. An inverse function undoes a function. Literally, that's what it means. It undoes something. So if we want the inverse function of f, okay, we could the inverse function of f, and we like to use a certain notation here, and it'll be this. We'll say f inverse like this. Undoes f. So whatever f did, the inverse of f will undo it. Okay? So in other words, if f likes to send 5 to 8, f inverse, okay, we'll call it f inverse here, we're gonna change it up, and it's gonna say, nope, now this is gonna be our range, this is gonna be our domain. Effectively, domain and range get switched, and our x and y's get switched. So and you'll see this. So this is just a little illustration to show you that exactly what's going to happen. F sends 5 to 8. So guess what? F inverse, the inverse of f is going to send 8 to 5. The f sent 7 to 9. So f inverse is going to send 9 to 7. And so on and so forth. Okay? And we get this new function. We can call it anything we want. We call it g, and realize it's the inverse of f. We call it f inverse and just say, hey, blatantly, this is going to be the inverse of f. And so we get these points here. We get 8, 5. We get 9, 7. 22, 8. 5, 10. And 6, 11. So here's the deal. It undoes it, right? So that means, on top of this, okay, what an inverse function is, and this is where we're going to get to, is really this, okay? An inverse function is going to be like this. Let me see here. Oh, here we go. This is okay. Given two functions, f and g, if f of g of x equals x and g of f of x equals x, then they are inverses of each other. Okay? And then we can use that notation with the -1. If we want to say blatantly, it's like, hey, that's the inverse. Okay? Sorry here. I must have missed it. There we go. Okay. Now, back up to here. Let's see if that's really true. What happens if I go f of g of something? Okay? In this example, where I specifically created an inverse, I had g undo f, or sorry, I had f inverse undo f. So what is f of f, or inverse of f? So f inverse of f of, let's pick one of these, 8. Let's say 8. Okay? Well, that's easy, right? What is f of 8? 8 goes to 22. F of 8 is 22. So that's the same thing as saying f inverse of f of 8, 22. Okay, well now I'm doing f inverse. What's my f inverse function? Well, it's over here. Where does it send 22? It sends 22 to 8, or I have this point here, 22 comma 8. Well, that means I get 8. F inverse of 22. So it's 8. And there you go. F inverse of f of 8 equals 8. In other words, f did something to 8, but f inverse is going to undo that. And so I end up with what I started with. Okay? That's the whole idea. And for us, effectively, what's that doing? That is switching our x and y values. The inverse will switch the x and y values. So I have this other visual for you guys to look at. Okay? And that's this right here. And it's a little thing I made some time ago. Right now I have a function here, 2x squared plus 3. It is not one-to-one, you'll notice. And so here's its inverse. Its inverse is not a function. We can mess with this, maybe only take half of it. If we took half of it, then we could get a function over here. But since this isn't one-to-one, it doesn't have an inverse. We'd have to mess with its domain. But if you can see, there's a couple ways we can look at this. I can just say, hey, you know what, x equals f of y. So just switch my x and y. So instead of f of x, right, equals y, which is my 2x squared plus 3, now it's f of y equals x. That means it's going to do whatever f does, but it's going to do it to the y and as its input and set it equal to the x. So that effectively switches my x and y's. So I'm going to get rid of this here, click on this, and see, there it is. What else? If I just look at this point here, say I got -1 comma 5, that means this function here is sending -1 to 5. If I want to undo that, I'll send 5 to -1. We get this point over here. And what's really neat is, and that's why we have this line here, every point that is a reflection over the line y equals x, which makes sense. Y equals x. We're switching y and x around. Here's another one. Easy point to look at. 1 comma 5. If I can get there. There we go. Be 5 comma 1. Reflection right over the line y equals x. And the way I'm getting b is I'm literally taking the point A and switching it. I'm defining b as the x value is going to be the y value of A, and the y value is going to be the x value of A. So I'm switching x and y around to get this. And then if I want to trace this around, you can kind of see it here. And I could turn on a trace, but here this actually gives me the locus of all those points, which is just the collection of every point along this path. We can see it. It's right there. It's and it's just essentially, it's like we're undoing it and we're switching every x and y value. There you go. So there's my illustration for you of what an inverse is and what it does. This has been a long enough, so I think in the next video I'll show you the procedure we'll use to, if we're given an equation in order to find the inverses. So until next time, enjoy doing math.